Okay, so we're gonna pick it up where we left off yesterday, which we're trying to fix our diagonal walking. And if you can see, our numbers are all over the place. And we kind of do this little jittery walk. So I'm trying to figure out how to fix that. Not sure what to do, but I've got a couple ideas, and we're gonna be trying something here, like if we go into our player, and actually, yeah, why don't we just, I'm gonna give us a value just called like a test x. We're gonna set it to 0, and then we're gonna draw a little square with this function here, and it takes in a fill type, and then an x and a y, and with the x we want to be our test x, and then y is fine at 0, and then width and height, let's just do like 15 by 15 so we can see it. Actually, let's just make it sprite size, so 16 by 16 so we can see it. And then what I also want to do is set the color for it. So love.graphics.setColor, and we've got a color, I guess, in our constants here. We've got we can set it, let's set it to this, just black. So if we do all caps black, we don't have to fill in all the values, we can just say black. So what this is going to do is render a black square at 0, 0. Now what I'm wanting to do is test basically how much one pixel looks like when we press it. So like what we're going to do to our test x is our test x is going to get incremented by 1 if our keyboard right is pressed. So if we press right on the arrow key, was pressed, so not for continuous input, but just for one press, then we're going to go ahead and say, you know what, I think I'm within a terminal inside Vim here, so, oh, I know what I did. Yeah, I didn't exit the terminal. There we go. Okay, where were we? Okay, so if right is pressed, we're gonna draw our square one more to the right. I just want to see what this looks like. Okay. So you know what, I'm gonna unrender kvothe real quick because I find it pretty distracting. So let me just, this is all kvothe, we can just turn him off real quick so I can focus. Okay, so what I'm trying to do is see how much a potential changing of the position will look like. So like let's say our x and y land in a non-optimal, a non-integer value. If our x and y hit that non-integer value, I want to place it right at a sweet spot of a perfect integer value just for collision detection and all that stuff in the future. So I guess I'm curious if I do this by 0.5. Huh. It looks like it can't render it. This might be the problem, because since we're using the virtual resolution, it can't render a 0.5. It can only render the next one once it's kind of over. So does that mean if we do a 0.33 that it would take 3 button presses for it to move? Yeah. Okay, so this makes it more difficult than I thought, because it looks like it's only rendering things at it's like it may say it's rendering the X at 1.2, but it can't render things in between pixels. So it's like it looks like it's just doing. So if we go back to 0.5, we'll see that it only works every other press. So even if we print our self X here for this test, it would be a 0.5, but it doesn't render it any differently. So this makes it more tricky than I thought to kind of fix what I was thinking. I think it's because we're tethered to that virtual resolution, and it can't render things at fractions of a pixel. Let's see. In the meantime, what I'm gonna do is I'll turn kvothe back on, and I'll turn our tester off real quick. We'll get our character back, and I think what I want to do is rehaul this sort of walking direction. Instead of doing 4 different values like this, a smarter way to do it is to not do it with booleans, but do it with a string. So instead of all this, we can say last input direction, or last directional input. Okay, and we'll start with down, so that when we instantiate, we overwrite to last directional input of down as a string. And then whenever we were doing this, instead of doing all this, it makes a lot more sense to just say, if right is down, then our last directional input is going to get right. And then same with this. Last directional input gets left. A lot cleaner than those 4 lines. We just have to make sure we change our render quads based on our last input direction, our last directional input, and then this should be the last one. And doing it like this will now overwrite whatever direction, like let's say we hold up and then we hold right. Then our last directional input will overwrite to whatever our most recent input was. So I'm hoping that if we set it like that, then we won't even have to set the stuff right here, the direction, upon our multi-inputs, because our single inputs handles it before we even get there. I would think that we can probably get away with that. So let's see. Okay, what are we doing here? Okay, so yeah, we don't want this here either. We should have already taken care of that with our single input reads. Because there can only be one value in our last directional input, and it gets overwritten every time something is held down. and then it doesn't get overwritten until another key is held down. So effectively it'll stay the same until another direction is held. So I'm kind of thinking we don't need to do this stuff anymore. And here's where we have to change it. Instead of our walking left boolean, you know, I've gotten I look like Zachary Levi before, and it was from Chuck. And when it was in Chuck, I was like, I don't think that's a compliment. And then I saw Shazam, and I was like, okay, I'll take it. I'll take it. So if our last directional input is equal to the string left, then we're going to go ahead and do our frame assignments. And then instead of walking right, we're going to do that comparison to be our last directional input equality with a right direction. And then if we're walking up, we change it to if last directional input is equal to up, and then down, and that should be the last one. Same with Neville from Harry Potter. People used to say I looked like him, and back when the first couple movies were out, I was like, no, I don't look like him, even though I did look like him. and then he glowed up, and I was like, oh, I look like him. Was it left there? No, down? Down. Okay. Let's see if that does what we're hoping. So remember yesterday we were trying to see if we hold right then up, if it would go up, and it's not. So I thought what we just did would fix it. Let's go ahead and print out that last directional input and see what's happening. So what we can do is print up last input, and then okay, we need to do what, 45, so we can see it. Okay, so down, up, right, left. Now, I guess the order it's happening is getting overwritten, so it still thinks it's right when it should be up, and that's because when we're doing our single inputs, where is it? We didn't even do it. Oh, no, yeah, we do it right here. Okay, so, oh, we only do it if our inputs held down is equal to 1. So we need to do it here as well. Okay. Because if it's... There's got to be a better way to do this, because I think, you know what, if... Let's not tether it to this. Let's not tether it to these blocks. We can have separate blocks that would do it regardless, and I would think if we check it outside of the number that's held, we might have better luck. So we're gonna do this. Last directional input gets up. And then we can say, and you know what? I don't want to do it in else ifs either, because if we hold more than 1, let's say we're holding right then up. And this should be love.keyboard. Love.keyboard.was pressed. Okay. Okay, so if we're doing it here now, let's just see if that works. Okay. So I guess it still comes down to the fact that when we hold multiple inputs, we're going to be overriding one of them. But we want the most recent one, and if both are held down, then it just becomes what order the code is in. So it's almost like anytime, yeah, it's like anytime we input a button, yeah, because how would we figure out what button was pressed second if both buttons are held down? Was pressed checks it once, and is down checks it for continuous input. Let me just continue on with this and see if it does mess up in the way I'm expecting it to. Because if it works, then we don't have to fix something that doesn't need fixing. But I'm pretty sure it's not going to work. Actually, we need right and left. Because here, like, the order we put this in will actually overwrite other inputs. So, like, let's say we're holding up and to the right, but we started holding up first. No, up. If we hold right and then we hold up, it'll say, hey, was up pressed? Yes, up was pressed, so directional input was up. But then it gets to right, and then it says, oh, well, last directional input is right. So then it would overwrite. Yeah, so it would still be broken. That is actually working. Oh, look, if we go right, and then yeah, if was up is pressed, you get not much watching the game having a bud. Okay, it seems to be working, because if we walk to the right then up, we see his head, or the back of his head, and if we go right and down, we see his face. Left and up, we see the back of his head. Left and down, we see his front face. So that seems to have fixed it. I would have thought that wouldn't have worked, but I'm not going to fight it. So let's handle that double input walking still. So like if we hold both directions, we're doing the moonwalk. So we need to change that. So like I guess what's happening there is, since up is held down, we're going to be going ahead and changing our quad. Where do we do it? I'm not even seeing where we do it. There it is. Okay, so if up is held down, we've got these two frames. So I guess what we want to do is say if down is, oh, and this is just last directional input, this is not. So it's almost like if we get, okay, bear with me here. So it's like our string last directional input is handling what frames to render. So and I guess, so like, what's the difference? Do we ever stop walking? Like if we let go of it, it doesn't animate. Oh, this is jacked up now. He doesn't do his little shimmy anymore. Okay, so we did break it with this. I think we did break it with this line. Let me see if we get his little shimmy back. Oh, it's not even... Okay, well... It's because we took it out of here. Jeez. Okay, see how easy it is to just go completely broke? Ask my bank account. Okay, so I mean, we need to set our last directional input based on the keyboard inputs, which we aren't doing at the moment. So let's just set that back. This was up. This was down. I have no idea what I just did. Okay. I didn't mean to do that. Okay. You know, in my head, I was like, I know exactly what to do to fix all this stuff. And then reality hits. I totally didn't even do the right. This needs to be right. Okay. And you know what? We're not getting our little shimmy anymore. Normally, we should default to standing up, not our squatting side animation, so I'm wondering when that broke. Oh, you know what? It's right here. This is where, because we hard-coded it in our walking right, and it's actually going to be in our, if our last directional input is equal to right. Then go ahead, do that, and then same with all this other stuff. Okay. Walking up. If last directional input is up. How's chat doing? You guys just, are you guys like playing with your babies? And have me in the background. We still don't got it. Ooh, the moonwalk is cool though. I'll take that. Okay, I gotta get that 3 concurrent viewers, right? Get that affiliate. Okay. Is frame 7 our standing up animation? Frame 7 is right tall. Yeah, it is. So why is that not getting set correctly? So last directional input is right. We should have frame tall there, not the frame small. And that's if none of the keys are held down, and if our last directional input is something like right, then we have a self frame of 7. I guess let me just, for giggles, put it at 1 and see. Yeah, it's not doing even the wrong frame there when we put in 1. So is there another walking value that we're using, we are not using those anymore. Yeah, we're just not, we're not defaulting to our specific sprites anymore. I'm not sure why. If it is called last directional input, right? Yeah. Last directional input's equal to the string, then we're setting our frame. Okay, but then we're doing this where we're saying, okay, well, whatever our directional input is, we're going to advance it, which we only want to advance this if we're actually moving, right? So instead of just arbitrarily advancing this, do we consult our dx or dy before we do it? Because we don't want to change these frames. See, and this is jacked up too, like... Okay, so I see what we did wrong is our walking left was based on our dx, whereas our last directional input's just based on whatever we press last, and it doesn't matter if we're holding it. So we would technically be animating even though we're not pressing any buttons, which is not right. But it's not doing that, so that's what's confusing to me. I wonder if we take out, well, yeah, let me just do a big ol' undo. Okay, I think we're at, are we at the beginning? Okay, yeah, so like there's the test block that we started the episode with. Okay, so we've got to do something different because our walking down, this walking up and walking down, that's based on our actual dx, so, or dy, so it's like if we're walking in any direction, we only set that if the key is continuously held down. So maybe we use that in tandem with our other ones of last inputted direction. But I'm still, because we need to remember the value that we're facing so that we can, I guess I'm still not quite sure what to do to fix that. Because we want, yeah, we want the most recent input to be the only one we're deciding on what direction we're walking. So the most recent input, we had the most recent input working before we undid all of it, but we've got to redo it. Last input gets down. So as long as we get the last input working, then we should say if the last input is down and we're actually walking down. And actually, I'm curious about what, let's see what it says if we print out what direction we're walking. So it's like if we go love.graphics.print, and what we're printing is if we're walking up, and that means we're gonna concatenate our value of walking up, and that's a Boolean, so it'll be true or false, and then we want to place that at 5 and 45. And then I'm curious what this says when we have multiple inputs is the thing. So if we go down left and right, Okay. And I'm curious if this is doing what... I actually don't know what it's doing. So like, I don't know if we'll be walking up and right if we hold both up and right. So this will be 5, this will be 6, and this will be 7. Okay. So it looks like we're only walking up if we're holding up and right. And we shouldn't be able to walk. Dude, we can walk off screen if we hold multiple inputs. Okay. Yeah, that's not okay. Okay, so it looks like we're only walking one direction at a time. It's almost like we need a walking diagonal, but it doesn't make sense because we need to... All we need to do is just keep track of what button was pressed last and default it to alternate between those two frames. Okay, so that is busted. So we've got a last input, and let's say that if any of our inputs are... See, yeah, this is the problem. We don't know what order they were pressed in on continuous frames. I think we need to do was pressed, and then anytime it was pressed, it just overwrites that value. I think that'll work. So if love.keyboard.wasPressed up, then our last input gets the string up. And we can do this for was pressed for all of our directions. Okay, so we've got up, down, left, and right. I've been looking into seeing how to get chat up on the screen, on the stream screen. I'm still figuring that out because a lot of the stuff I found was for Windows only, or so I'm gonna figure that out. It's just not there yet because I've been watching more chat on. I've been watching more streams on my phone, and I notice that it is kind of the chat function on the phone is a little annoying. So it's nice when it's just on the screen and you can full screen it and everything. Okay, so let's print up this last input and see if this is working. And we got to remember to change our Y so we don't accidentally overwrite our other debugging. So okay. Okay, so we're almost there. Down isn't working well. No, down is working. So if we walk right then up, we see the back of our head. We walk left then up, back of our head. Right and down, see our face. Left and down, we see our face. So that's working. So, oh, look at this. Okay, never mind. There's a way, I'm holding both left and right now, and it's stationary. But it doesn't work if I start holding one and then hold the other, it doesn't work. But if I hold them both, then it doesn't advance. So it's almost okay. Okay, we gotta fix that. We can, we shouldn't be able to do that. If we walk, if we play nice and just hit down, we can't go into there, but if we diagonally walk, we can cross into it. So I guess, where is that clamping? Only on the is down is left. Okay. Okay. Yeah, it's almost like we've got to... It's almost like we got to just go ahead and update our X position, and then after all the inputs, we just check if we're out of bounds and put us back in bounds, but then I guess we have to determine how we're out of bounds. Yeah. Because we're only clamping our X on a left input. We're not clamping our Y position on a left input because we wouldn't be going down if left is held. But when you do multiple inputs, we can go diagonally off screen. I guess I don't get why it's allowing us to do that still. Okay, I mean, I guess let's just say oh, see, this is only if one input is held down, so we have to make sure we clamp on multiple inputs, which we kind of are. I guess we are. So if up and right is held, we're going to clamp our X to the lower of either our current X position or our right side of the screen, and we're clamping our Y to be the higher of two values, either our Y minus our current position or 0. So clamp us to the top of the screen. So Y is down and right, allowing us to go off screen. If down and right is held, we're going to set our X position to be our current X position, whatever the smaller value is, either our current X position or the virtual width minus our self width. So clamp it to the right side, no further than the right side, and then Y, our max gets our current Y position or 0. See, that's wrong. Not 0, it should be virtual height. Because we want, is that right? If right and down is held, we want to clamp it to no further than the bottom of the screen. So we want our Y to be clamped to either our current Y position or the smaller of two values. So I think we might have this wrong. Should this be math.min? And then if X, our X position, if we're going to the right, it's either going to be, we want the smaller. Am I thinking that through right? We still walk through. It sets us... I don't know why. Okay, well... yeah, we're updating our dx and dy, But then if we're out of bounds, we need to move us. So we're setting our current y position to be equal to, I swear we want this to be math.min on the y position, because we want, like, let's say our y is 250 at the very bottom, or whatever it is, 144. We want, if we're below the screen, our y would be, let's say, 150, but we want it to be clamped at 144. And actually, actually we want it clamped to not the y of the virtual height, but since this is the bottom, we have a special constant for it, because there's that's the bottom of the screen, not bottom of our special spot where we're putting our, it's called screen height limit, because we're rendering that thing there. So screen height limit needs to go here. But then that's not even right either. We need to subtract our self.height so that we clamp to the top of that. And then our x position needs to be, if it goes past the right side of the screen, it'd be above 160. So we want to return the smaller value. So another math.min of a virtual width minus a self.width. That might be it. So let's see. We can diagonal hack it. Oh. We got down and right. Down and right isn't hacking it, but down and left is. So we need to go fix that. So where is down and left? Here. So yeah, we want to clamp our y not to our y position and 0. Well, down and left, this is jacked. This shouldn't be that at all. So down and left, x is 0 if we're at the bottom left of our screen, and y would be screen, what was it, screen height, screen limit height, god damn it, forgot what it was, screen height limit. So we want to clamp our y position to be the smaller, so we want a math.min here, and we want our current y position or our screen height limit minus our self.height. And then our x, we want the greater of the two values, either our current x, or this should just be 0, because down and left, yeah, this should just be 0, I think. Let's see. Okay, so down and right and down and left both don't clip us out of bounds anymore. So what about up and right is still jacked? Looks like that's fine for the top clamping, but we can clamp out the left, sneak out the left side. It looks like we're stuck on the right, which is good. It's just that we can get out if we do left and up. So let's see left and up. Okay, so we're setting our x position to be, I can already tell this is wrong because we want math.max here to a 0. Because we want, we don't want our x position going any lower than 0. And our y, we don't want it going any smaller than a 0, because it's the top left there. So, not right. Our y is set to this, bigger. We want our y to be the bigger number, which is going to be 0 if we go up and off the screen, because a negative y would be above our topmost border. Okay. Okay. It looks like we're successfully trapped now. Just testing all the inputs, making sure we can't squeak out. Okay. Okay. Yeah, looks like we're stuck. Okay. So we've got the good directions. Let's go back and try to figure out. So one thing I realized is like even though our x is a 121.8, it's not rendering us at a 121.8. Its virtual resolution only knows of the integers. So it's rendering us at 121 until it hits the next integer or whatever. So I'm wondering if the judder is part of that decimal point imprecision, or I don't know. Let's set. Is this the first place we're doing our diagonal dx? So what we're gonna do, we're gonna try this again. And let's say we want to limit it to that 10th position. So we're gonna say we get that half of root 2, and we're gonna multiply that by 10 and then floor it. So we're gonna say math.floor gets that value. I want to make sure we're doing. See, I guess we want another quote parentheses here, because we want to say do that first, then we multiply it by 10, and then we floor it, and then we'll divide by 10 to get the 10th place, truncated at the 10th place of precision. So let's try that. So we're gonna do that root 2, half of root 2, multiply it by 10, floor it. Oops, yep, floor it. Then we're going to go back and divide by 10. So this should be up and right. So I'm hoping if we press up and right, we only have 10th precision numbers. Yes, instead of those huge amount. And actually, it does look like it helps the judder. Because look at how juddery he looks like that. Well, I guess it still looks the same juddery. So I was imagining things. Still looks pretty juddery. He looks like he's like driving on old tires on a bumpy road. Well, what's weird is sometimes it looks smooth. Okay. Well, and what's weird is now we don't have the 10th precision. Whoa, that's weird. Yeah, we don't have the 10th precision numbers anymore. Because look, if we do it, and actually, yeah, that does look better. But as soon as we go another direction and then back to up, then we're back at the bigger numbers, or the more decimal place numbers. So why is, I guess if we just do this for every direction, maybe it'll look okay. So we're gonna do this double parentheses, make sure PEMDAS is happy. We multiply it by 10, and then we divide by 10 to get that 10th point precision. Multiply by 10, and then divide by 10. Okay, and actually, this is the same line of code. And you know what? There's something to say about how we're doing it. Is we're just calculating like the actual velocity, and then in our updating, we're determining whether or not we subtract the velocity or add the velocity. And we could make the decision to just go ahead and default to always adding the velocity, but giving a negative velocity when appropriate. So we'd be adding a negative. That's just totally a design decision that we can choose. But that means, at least right now, it's the same code for, that's not right. It's the same code for every multiple directional input. And it's getting that 10th precision decimal. So look at that. We've got our 10th precision decimal, but we're still, I guess I can't tell if it looks better. Does it look juddery to you? It still looks a little. And you know, I've had some problems, like I can't tell if, since I'm recording my stream and live streaming and doing a game and running music, my processor might be a little strained, so it might look worse on my computer while I'm streaming. Oh gosh. It's like we're getting some frame bleeds on the pixels sometimes, like, see, look at that. Why is that happening? And what sucks is I can never recreate certain bugs like that. Like I'm trying to do that bug again. Can't do it. Can't do it. I don't know. I think maybe off stream I'll build a little keylogger down here so that everyone can see what keys I'm pressing for those inputs. So it's a little more interesting during those testing aspects. You'll see what keys I'm pressing and see if the appropriate thing's coming out. So we can add that. That wouldn't be too tough. But we're not really fixing our jittery problem. Parts of it looks better, but parts of it looks worse too. So I'm a little torn on if we keep it or not. Yeah, I don't know. At least this way I haven't seen it mess up that viewport for the sprite. But what just happened? M151 in play state. We're right here. Math.m. Okay. That is going to be up and to the left, which means we want our y to be no smaller than, so we want the bigger value of our current, or 0. Okay. I still don't know. We still don't have multiple directional inputs doing nothing. We still don't have that. You know, I think, Fartknocker, I think the game is treating it as if it's an integer anyway, because of the way our render library is set up. We're using this library called push to scale. Here's a good test actually. We can go, if we go into our constants and we take our window height, and we, instead of giving us a big window height, we instead render our window at the same resolution of how push is treating it. So I think that's the thing there, is push is only doing Push is treating it as if they're only integers anyway. Oh my god, he's really cute still. You know, it looks totally fine. It looks totally fine at that size. Yep. I wonder, yeah, I don't know if is there a zoom accessibility zoom or something I can do? Here, zoom, magnifier, follow the cursor, zoom a bunch, zoom on, oh god, okay, hey, oh my god. Can you guys, did that zoom in for y'all? Yeah, it looks like it did. Here, let's try that. So if we turn zoom on, oh, he's so cute. Okay. Okay. I guess it still does kind of look a little jittery. But now the Linux zooming could be messing with it, so I'm not exactly sure. Okay. But that's so like the first thing I did when I was testing it, and what we can do is we can leave this as a toggle for original resolution. If we want to ever do a test like that again, we can just kind of save that. If we go into our player state and we go to our test, we've got this test X, and we're rendering a rectangle at that test X. And what we're doing to that test X is if right was pressed a single time, we're going to increment our test X by, and here's the thing, if we do a non-whole integer, we do a decimal here, then pressing right didn't actually move it, but pressing it again moves it 1 pixel, but pressing it one more time, no movement, then movement. So that's at 2. 2.5, no change. 3, it changes. So that's why I think push is already treating it like it's an integer, because it doesn't care about the floating point. It's got a floating point, it just renders it wherever it wanted to. So I guess one way to address this maybe is we don't use push and we just set a hard-coded resolution about this size. This is a bit too big for my laptop, so it'd have to be maybe a bit smaller, because my laptop's only 800 pixels tall, but this is the size that's good for showing off. And the other thing is, I'd like to be able to full screen it, which is why I use push in the first place. But when I full screen it, when I full screen love, OBS doesn't pick up that footage. So it's just a black screen, and I've done that so many times where I stream the full screen and I'm reacting, and then it's just nobody knows what I'm looking at. So I like to have push so that we can full screen it by the time we deliver the game, but it might be causing these problems. You know what? So like after today, after this stream, I said I was going to stream about an hour, so after this stream, I'm going to close all my processing and see if the computer handles it differently without streaming and recording and playing music and the graphics in the background. Maybe it'll look a little nicer, and then maybe we'll just move on, or we might just have to dig around a bit and still do it. Because like I want to be, if I'm not happy with the character movement, I'm not going to be happy, you know, programming each part of the game because I'm like, oh, it looks so gross moving diagonal. So I really do want to fix that. But that was good. I mean, we got the correct directions upon multiple inputs, and we fixed the clipping out of bounds, which was totally off. I don't know how I didn't notice that sooner. What I'm going to do is just turn off our test rectangle, and then we can go ahead and check our git diff real quick to make sure we didn't mess anything up. So we do have this new last input variable, and that's what we're using to actually change. And where do we actually do this? We set it, but we're not actually... Are we really not using that anywhere? We're printing it up. We gotta be using that. We're really not using our last input? I thought that's how we were setting. Here, let's see, last input. We set it there and then we don't use it. So what the heck? How did we fix the last input problem if we're not even using that? See, I was thinking we were setting our sprite walking animation based on that, but we're not. I'm a little stumped, to be honest, because it's like, we're not using the last input. We kept all that. Was it really fixed before we even... Oh, no, yeah, that's just our debugging, so we're not even using that. Well, it's fixed. It's fixed, but now I'm tempted to just remove that last input. Because we're not actually using it anywhere. Yeah, I guess it's working because where do we set our frames? We set our frames down here based on what direction we're walking. So did we change the direction we're walking based on a certain order of operations, or did we just happen to get that right? Okay, well, up and right walking up is true. But if we're up and left, or up and right walking up is true. And then up and left walking up is true. Okay, so yeah, I guess we fixed it in here. Down and left would mean... But left and... yeah. Down and left should mean left. But it's just down. So let's see down and left. Down and left. Yeah, see, you know, we didn't fix it. Down and left should be left. But we're not. Down and right should be right, but it's not. It's working for up, but... And left down is working, and right down is working, but down and left is not. And that's That's the order of operations here, which is a little tricky to fix. But if it's down and left, we can be walking down unless our last input, I guess we can say our last input is equal to left, then we should be left instead of walking down. Not okay. Yeah, so we would take this, we would make sure that this isn't an else. Yeah, we would make sure this is in the else block here, and then we would change the one direction to be walking left to be true in this case. So this can be true, this will be false. Only walking left if our last directional input was left. See, that's correct now. So down and left is now left, but then left and up is up, left and down is down. Down and left is left, and up and left should be left too. Yeah, up and left should be left as well. So let's go do that. Up and left should be left. So up and left. First thing we want to do is say left. If our last input's left, go ahead and do that. Otherwise, we're going to go do this other stuff. Okay, and then we need an end. So let's test that. Up and left. Up and left should be left, but we're not moving left anymore. Why does it do it? Why does it do it? Left and up is working. Up and left, not working. It's got to be if last input is left, then that. Otherwise, do all that other stuff. Okay, we just need this outside of our block. Okay, now up and left should be working. So, yes, up and left is working. We need up and right. We need down and right. So let's do up and right and down down and right. And then we'll call it a night. Up and right, we need to check if the last input was right. And if it was, then we are actually walking right. And then else all this stuff, and we need to end that block and then do that other stuff. So up and right should be working now. Now let's get, was it up and left? I already forgot. So down, right and down is working. Right and up is working. Left and down is working. Left and up is working. Up and right is working. Up and left is working. Down and right is not working. Down and left is working. So down and right is the last one we need. So down and right. Okay. See, and that's one of the reasons I always try to check my git diff, so I can catch things like that. Oh, and you know what? We need to double check. We need to double check our math on those other ones because we copied and pasted those. So down and right, if last input is right, then we're going to be walking right. That should be correct. And then we should be walking down otherwise. So let's check our other ones. Down and left. If left was our last input, we're walking left. We're walking down otherwise, yes. Up and left. If last input was left, we're walking left. Otherwise, we're walking up. That's correct. Okay, up and right. Last input was right, we're walking right. Otherwise, walking up. That's right. Okay, I think we're there. So, right and up, that's good. Right and down, that's good. Down and left, that's good. Down and right, that's good. Left and up, that's good. Left and down, that's good. So, now depending on the last input, we still got to handle that multiple inputs. Okay. Well, we've got our last input direction working, so that's good. That's a success. So we'll go to our notes and we'll actually say, why don't we have our notes harpooned? We'll say we want to. We already got fix our judder step, but what we did was added last input animation overwrite. But what else did we want to add? Yeah, we still need to figure the judder walk. Still need to prevent walking animation. Oops. Because we don't walk. Our velocities cancel out, but our animation doesn't. Okay. Okay. All right. Well, we do want to do this, but I'm not sure we're gonna find a fix for that one. So. That'll just be perpetually in our next episode section. But we'll go and check our get diff again, and we'll see we did add that last input animation overwrite, and we are actually using our last input variable now, and that is actually working. And that fixed the thing we wanted to. I'm gonna just check that my initial stutter step is still working, because we accidentally broke that last time. Yep. So like, remember we like sat in the squat animation on the side? We don't ever want to sit in that squat animation. We default to standing up on the side. And then we default. And you know, we don't, and it's because if you do it quick like that, it looks like a starfish and it's funny. That's why we keep that in. Okay, so let's add our commit message here saying we added last input overwrite for kvothe animation. And then I will check off stream and see if it's looking less juddery. I'll check it on my laptop, see if it's looking less juddery. And then also I might make the keylogger for next episode, so that can be on screen, and that'll help you guys see what buttons I'm pressing when I'm testing these things. But I think I'm gonna try to do 8 p.m. streams, and I'll try to limit them to 1 hour. So in the morning, I can like do some research, try to get a game plan together about what we're gonna code, maybe test some stuff, and then do a shorter stream, a nice focus stream like this where we try to get 1 or 2 features done, and then it makes for a nice, a tighter episode. So we'll give that a shot. But thanks for watching, guys. I really appreciate it. I'll catch you guys in the next one.